Morning. Hope everyone is well. I hear you guys have had a very um, cold front coming through. So I like that time of year when the seasons change toward fall and or winter. But anyway, I understand it's quite cold. Good morning, Zach. Good morning, Justin. I saw in chat. Good morning to whoever was able to make it, and hello to you if you're watching the video later. We're in week 12. We're way down to the small end of the semester, so that feels good. Okay, in terms of what's going on, so the team projects, I know those can be frustrating, and I hope that most of you had a workable experience with that. We're going to do another one, and remember, I'm always available as a spare team member if you feel like you got abandoned, or we can shuffle teams around if everyone's gone. So anyway, by the time I see you on next Tuesday, I will have read through those. I'm not going to grade them super mean or super tough. I just want to see that people had that experience. I think it's useful experience, particularly for the system administrators, but also for the programmers in the class. That you know what's available to you in terms of different Linux distributions, that you have a sense of their strengths and their weaknesses. You have a sense of what kinds of users prefer, say, Ubuntu over CentOS. That's the reason for all that experience. And also, hopefully, that you emerge from it with some confidence that if someone says, hey, have you ever tried out Arch, that you can say no, but I'll go home and fire up a virtual machine and I'll play with it a little bit and let you know what I think. And then just from my perspective, you've seen a little bit of the kinds of things that I tend to look for. What does the package manager look like? I often look at how often they do security patching, how often they do software updating, how often they do well, those kinds of things. You get it. And you saw the document. So anyway, we have another one of those. It's due in about a month, so this is all I'm going to say about it this week, although you'll see it in the reminders. Project 2 is exactly the same. So I did have Canvas randomly make teams, so you may not have the same team members, but it's the same project. You, as a group, pick a distribution and you try it out a little bit, and then you fill in exactly the same template based on your impressions and your experience with that distribution. Okay, so we're doing something super, super cool this week. I hope that you like it. This is some of my favorite content in the class is regular expressions. Regular expressions can be maddening, but it's a little bit like a game. So when you actually get a regular expression that you have handcrafted, and it actually gets you the results that you want, it feels really good. It's just a really neat thing. And I think you'll find that they are very, very useful if you're a system administrator and or a programmer, that you'll find regular expressions very, very, very useful. Okay, so our goals for the week. To get a definition of regular expression, I'll give you my definition, but you can find many different forms of it. Of course, your lab assignment, one of the choices should be very obviously the definition that makes sense for regular expressions. We'll talk about the basic building blocks of regular expressions. We won't go into the entire language of regular expressions, but we'll talk about the most important parts, or at least the fundamental parts of regular expressions. And then we will use a few utilities, the grep utility, the sed utility, and the awk utility, all three of which make use of regular expressions. So if you want to get a feel for how regular expressions work, grep, sed, and awk are a good way to do that on a Linux system. Grep by far the best, by far the simplest way to explore regular expressions. Sed and awk are power user tools, so hopefully the exposure to them that will give you something else in your toolkit that you can use someday when you need to filter or edit or in some way in a process text in a sophisticated way. But all of them use regular expressions, so that's why these are together, is because we'll talk about what is a regular expression, and then we'll actually use Linux utilities to experiment with regular expressions. 3 chapters, sorry about that. And I mean, none of the chapters is long, right? But we are kind of drawing on parts of 3 chapters this week so that we get the regular expressions part and the utilities we're going to focus on mixed in as well. The lab is always the Piazza discussion. So a couple of people have already gone out and found cool stuff. So kind of like when we first encountered VI, I asked you to go out and maybe find some websites or some games even that help you learn VI editing skills. So we're going to repeat that, but for regular expressions this time. There are, if you go looking on the internet, there are a bunch of places that allow you to experiment with regular expressions. Some of them take the form of games, like there's a, if you're interested, you have to go look it up for the discussion, but there's, I think, a regular expressions golf page that's a game, basically. So there's a lot of places where you can go sort of practice and hone your regular expression skills, which are very much power user skills, which all of you either already are or well on your way to becoming, in my opinion, power users. And then the reminders. So I don't think you have to worry about team project this week if you need a break, but we do have the Thanksgiving week coming up. We'll have class as normal that week, since Butte College always does, but you might want to consider getting some communications going before Thanksgiving happens. So I'll press harder on that next week. Okay, so there's all the introductory stuff. Let me switch the view and let's do some regular expressions things. Pardon me, it's clearing my throat. Maybe? Okay, there we go. So let me log in, and I'm going to build up a picture of what the building blocks of regular expressions are, and sort of do command experiments at the same time. So there's my .bash _ profile thing. I need to get rid of those echo statements at some point. Okay, so where was I? Oh, regular expressions. So we're going to use grep first. On my notes, you're going to see ls. Ls kind of has limited regular expressions functionality, but it's really more easily used in combination with grep, which is why you see the note about if you pipe an ls through grep, then you can use grep as a filter on ls, which I'll show you a couple of usages of that. So let me just start in this folder and do an example of that, hopefully. Okay, so one easy one would be, well, let's see if we can pick off all of the folders that have like week 10, week 11, week 12, week 13, week 14, week 15, week 16. There's a couple of ways to do that. So it should be, in theory, true that I can say, so this is the ls utility with its sort of limited regular expression support. So I can do an ls command and I can say, okay, I want all the stuff that has week 1. Now if I do it like that, I get no result because there isn't anything in here that says week 1. But I can wildcard it using ls, and what the wildcard does is it tells the ls utility anything in this directory that has week1 followed by anything else, which is what the wildcard means. It's the same as in Windows and on the Mac. The wildcard character is what we call it in this context. And then we get a listing of week 10, because that was WEEK1 followed by anything. In that case is 0, and then week 11, which was followed by a 1, followed by a 2, followed by a 3, 4, 5, followed by a 6. So that's kind of LS using a regular expression. Now, I didn't define regular expression yet, but all a regular expression is a string that represents a pattern you want to match. So let me redo that LS one. So the regular expression here is the string WEEK1 followed by anything. So the star means followed by anything. So that's the pattern that I want to match on is WEEK1 followed by anything. Which in this case gives me all those things. And you can use that wildcarding for lots of LS filtering. So I could, for example, say anything followed by .txt. So my pattern now is anything followed by .txt, which will list me all of the files that end in .txt. Let me see if, okay, yeah, so let me do another one. So I can also say I want to list everything in the current folder that is anything followed by a K followed by anything. So what should match is desktop. I'm looking for anything with a K in it. Week 10, week 11, 12, 13, 14, 15, 16, week 4, week 5, 6, 7. So all of the week folders plus desktop are match that pattern. So my pattern being anything with a K followed by anything else. There's desktop at the top, and then week 10, 11, 12, 13, 14, 15, 16, and then there's week 4, 5, 6, and 7. So as expected, every entry that was anything with a K followed by anything matched my pattern. So regular expressions are a string, and the string is used to represent a pattern that you're trying to match against. Keep looking at what I got here. So hopefully that makes some kind of sense to everybody. You can also do things like this. So let's add over here from my regex notes here. So we've been using this star, which is 0 or more of anything. Now we're going to add the square brackets. So let's say that I want to find, I'm looking for the pattern file, but I want to find that only when it has the digits 2 or 3 behind it, followed by .txt. So the square brackets is called a character class pattern, but what it means is one of these things. So what I'm looking for in my listing is FILE followed by a 2, or FILE followed by a 3, and then either one of those followed by .txt, which I get file2.txt, file3.txt, but notice I didn't get file.txt because it didn't have a 2 or a 3 at the end of it. So I could do the same thing on the weeks if I wanted to. I could say week, and then let's just say a 1, but followed only by, let's just say the even ones, 2, 4, 6. So now what I'm looking for is the characters, the string or the pattern WEEK1 followed by a 2, or week 1 followed by a 4, or week 1 followed by a 6. So when you put it in the square brackets, that designator means one of these at a time. In which case I get week 12, week 14, and week 16, because those were the three the three entries that matched the target pattern. Okay, so we're almost to where we've gotten everything we can get out of LS. Oh, good. I have a week 12 folder with a whole bunch of stuff in it. So I'm going to change directories here, and let's go talk about grep, and then we'll add in a whole bunch of these other searching, regular expression, pattern matching symbols. So let me go into my week 12 folder. All this stuff should be documented in the hands-on experiments page for the week. So I've created a whole bunch of files so that I can play around with different forms of regular expressions. Inside of my shopping list, I've put a whole bunch of things in. So before you do the lab this week, as is often the case, I recommend that you make yourself a copy of this file, because I was using this file as I wrote your questions. So I was kind of doing my own hands-on experiment looking at the results I got out of this file. So I'm here reading it just to make sure I remember what's in here, so we can use some regular expressions. Okay, so I want to point out to you that we just did a sort of kind of regular expressions with the ls command, but it doesn't actually do true regular expressions. So when you're using ls, as I've noted here in my notes on the side, if you want to use actual regular expression language, then you should take ls and pipe it through grep. So using grep, we can actually begin to experience really what regular expressions can do. So what I'm going to do in my first search is I'm going to look for the word apple everywhere. You should note that regular expressions are case sensitive, but let's just start with the simplest of regular expressions and then build up from there. I'm in the wrong place. I messed up my whole file. Okay, get back in here. Okay, so before we get super fancy with regular expressions, the most basic of regular expressions is just literally what you want to find. So if I'm looking for literally the word apple that starts with a capital A in the file shopping list, then my regular expression can just be literally the pattern I'm looking for. I don't have to use any special symbols. I just literally say what is it that I'm looking for. And if grep can find that in the file in question, it will print it out. Now I like CentOS for this a lot, that it sort of has, it's defaulted to making things colored up. So notice everywhere where it found the pattern APPLE, it printed that out. Notice also that the pattern can appear as part of a longer word like apples, but it still matches. So it's just literally where is that pattern. I'm going to grep for little a apple in there and see if that appears anywhere. It appears once. So that's the most basic of regular expressions, and you should never forget that. The most basic of regular expressions is just literally the string of characters that you're trying to match on. So if literally you're looking for the word apple, then just say apple. That's it. You don't need any special characters around it or modifiers or anything. Now you notice in these two searches, the capitalized apple didn't show up, but the little a apple did. Now there's two ways to make this case insensitive. One is the grep way to do it, which is to use the grep option -I, which makes your search case insensitive. So you can actually just tell grep be case insensitive, in which case, by the way, it finds a whole bunch of different combinations of the spelling of the characters APPLE. So that's in a case-insensitive way, everywhere where any combination of upper and lowercase a, p, p, l, e appears in that file. The regular expression way to do that same search, or a similar search. So let's say, for example, I want to find all of the capitalized apple and lowercase apples. I can use the character class and say one of these, big A or little a, followed by PPLE in that file. So now, instead of using grep's case insensitivity, I'm going to say, well, I actually want little p, little l, little e, but I don't care which I get of the big A or little a on the front of it, and now I will get the capitalized and uncapitalized apple by using the regular expression language, where I say one of these things, which is kind of cool. So let's add another one. So in regular expression language, a dot means any one character. So I can, for example, look for the characters PPLE preceded by any single character. So that's here in my little notes. In regular expression language, a dot means any single character, I don't care what it is. Now I only get Apple's stuff from that, but if PPLE had appeared, well, let's try just PLE preceded by any single character and see what we get. So we get PLE preceded by an A, PLE preceded by a P, by a P, by an A, by an A, by a P, by a P, by an A. There's a whole bunch of misspellings of apple in there that I put in there on purpose. So the dot can be used with grep, with regular expressions, to represent any one character. I don't care what character it is. You can also do, so if I were to do this, then that's any character, PLE. So that's PLE preceded by two characters of whatever it is they happen to be. So notice it's picking up, in this case, the space, I would assume, the space, which I didn't want a space, but that's what I got because I put any two things with PLE after them. Okay, so that's the dot. It means any one character, and you can use it on either end or mixed into the middle of a regular expression. So that's PP preceded by any character and succeeded followed by any character, which is still getting a whole bunch of Apple stuff. Let me look at that file again. Actually, I'll just cat it out so we can see and then sort of do meaningful searches inside of it. Okay, I'm going to do the big ones first, and if we have time, I'll do the small ones. That's the dot. Let's do anchors because that's important for the lab this week. So you can, if you want to. Let me see if there's an example here. Here is, for example, the word apples at the end of a line. Is there an apples somewhere not at the end of a line? Let me block that real quick. So let's find something interesting to search for so we can prove how these anchors work. There's apples at the end. Is the word apples in the middle? Just the word. I should have put that. Oh, it doesn't matter. Oh, I have another file for that. Let's do the basic ones first, and then we'll use my other file for that thing, for the anchors. Or not. Julius apples at the end, but not apples at the beginning. Okay, let's do this instead. What I'm going to do is I'm going to do a search for the lines that have an S at the end. Well, first I'm just going to do a search for lines that have an S in them. So S is all over the place. So we can, if we want to, use an anchor to say only when S appears is the last thing on the line. So I want S, but I want it anchored to the end of a line. So notice here it's only picking off the lines that end with an S. We can also anchor to the front. So if I grab all the capital A's, I'll find that there's capital A's all over the place. But if I only want to know when a capital A appears at the beginning of a line, I can use the caret to anchor to the beginning of the line. So this is only A's that appear at the front of the line. And then I only get the lines that have an A at the front. So that's what anchors do. They allow you to pin your search pattern to the beginning or the end of a line. There's also word anchors. So let me do an example. Let's do that case insensitively. Okay, so we're going to do case insensitive, but notice that we're picking up plural apples all over the place as well. So if we only want to find apple when it's a whole word, in fact, well, we can anchor it to being a whole word. So only when the A is the first letter of the word, and only when the E is the last letter of the word. I might have to put quotes around that to get this to work. Yeah, I have to put quotes around it for something fancier like that. So notice though I don't get plural apples anymore because I've anchored my string apple inside of the beginning and the end of a word. Technically I can probably just anchor that search where that lands at the end and get those same results. And the point there is that you don't have to anchor to the beginning and the end. You can just say only when apple appears at the beginning. In this case, notice I get apples again because I wasn't sort of trimming off at the end of the word. So that's the word anchors. Okay, let me see what else I got to work with in here, and also monitor the time. Okay, I'm doing okay on time. Okay, it's actually probably enough that we can move on to other stuff. I put a couple of other symbols in here that we'll probably come back to when we have time to do fancier regular expressions. But you can say something like this. I'll just show you how it works real quick. So what we can do is we can say, I want to search for everywhere where one or more P's appears in sequence. Now that's not super useful, but let's see what happens if I do that search. I probably have to put quotes around it to get the fancier symbol in there. I'm not. I guess there's not one or more P anywhere. Well, that can't be true. Oh, I know what it is. Let's do a P followed by, I think it'll work if I do this. Nope. I'm running into some kind of grep hiccup. So what I'm going to do is to save us all a bunch of pain and just get rid of those for now until we actually have time to talk about them. We don't need them for the answers for the lab this week anyway. Okay, so I'm going to reset myself a little bit and just point out to you and then finish on grep. Don't forget that the most basic regular expression is always just precisely what you're looking for. You can use character classes to allow for differences in spelling. You can use anchors. And grep's going to want me to put that in quotes for this to work. You can use anchors to say I'm only interested in the characters A, P, P, L, E when the A is at the beginning of a word and the E is at the end of the word. In this case, that doesn't appear anywhere. I think that capital A does. It does. So you can use anchors. You can also anchor things to the end of a line with the $sign. So apples only when it appears on the end of a line. Or apples only when it appears at the beginning of a line, which there weren't any. Oh, because I did an all caps one. So we'll also use grep in this case to be case insensitive. Except for I got to put quotes around it. Oh no, there was no S. There was no S. That pattern just didn't appear. Okay, so a couple of other things about grep. So, case insensitive search for Apple and shopping list. You can also ask grep to print out the line numbers where the matches happened, which can be useful if you are in editing mode. You don't have to use the -I, by the way. You can use the -n independently. So that specific one, but you can use them in combination with each other. The other interesting one is, I'll do the case insensitive search for Apple again. The -V option says show me the lines that are not matches. So it's sort of the inverse. Show me all the lines that don't have Apple on them. And these are all the lines in the file that actually don't have the characters A, P, P, L, E in a case insensitive way on them. So the -V option tells grep I want the opposite of the search. I want all the lines, in fact, that don't have Apple. You can also combine that with -n to get their line numbers. Those are all the lines that don't have A, P, P, L, E case insensitive on them. You'll see this stuff come back, these basic ones. So before you commit yourself to an answer on the lab, just try it out in your virtual machine and see if it does what you'd expect. But I did write the questions assuming that you have some of these files to play with. Okay, so that's grep. Grep is a good place to experiment with regular expressions. I just noticed that for some of them on CentOS I needed to put quotes around them, so keep that in mind. It's probably true, by the way, that you can just always use quotes. Yeah, so if in doubt, use quotes around your regular expression. Now I also have a file called ratings. Edit anyway. So I also have a file called ratings, so I also wrote questions against this file. So it's repeated in the hands-on experiments, but the way this file is set up is it's kind of like a little database file, a little text database. So every line, pardon me, has 3 pieces of information on it. So the first field is a category of food, snack food. The second field is the name of a product, Fritos in this case. And the third field is my personal rating scale. So Fritos are yummy in my rating scale. But we're going to use these with regular expressions to search our database. So the second one, for example, so the category on line 2 is breakfast cereal. The product is Fruit Loops. And my personal rating is yummy. The third line, the category is vegetable, the food is okra, and my rating is yucky, and so on. Just so you know what these things mean. So pretzels are meh, gummy bears are meh, Wheaties meh, the squash yummy, apple juice meh. So you get the idea. It's a little bit silly, but I wanted to do it so we could use regular expressions against it. And also use sed and awk with it. Actually, I had another use of the other file before I did that. So we can grep all the yummies. Which will show me all the yummy things. By the way, if we grep the ummies, we actually get the line that has gummy bear in it. So we might want to anchor that ummy to the end of the line in this case, so that we don't get accidentally some product name that has ummy in it. We just get the stuff that's yummy at the end. Okay, so we'll go back to shopping list for a few moments, and then we'll come back to ratings. That's all I'm going to say about grep, I think, for now. Okay, but if in doubt, man page has a lot of stuff on it, but I'll just point out to you that I was using the ignore case option, the invert match option, show me what doesn't match. There's a -W option, which will pin you down to specific whole words. There's a count option, how many lines matched. I was using the where is it? The -N option. So notice grep has a whole bunch of options, and strongly, highly recommend that you try out some of these options just to see what they do. But I think I pretty much talked about the ones that you'll encounter on the lab. But if in doubt, try it. If you see an answer on the lab, try the command variant with the option and see what it does. Okay, so now we're going to use sed. So sed is called a stream editor. So sed's job really is to allow you to perform edits of text on the fly. And I'll show you what I mean by that in just a second when we try it out. It's got lots of options. I'm not going to use any of the options. I'm just going to use sort of simple sed commands. But sed also works on regular expressions. So let's try it out. Although I can't remember what the -N does, so we'll try that out. Actually, let's look and see what the -N does. I wrote it down as something I wanted to mention to you. Didn't see it. Oh, suppress automatic printing of pattern space. So we'll try sed with -N and without and see what happens. Okay, so sed, that stands for stream editor, and its main job really is to allow you to apply alterations to text as you're filtering the text. And I'll just show you a quick example against the shopping list. So notice that I've misspelled apple a few times, A-P-L-E, A-P-L-E-S. So I purposely misspelled that. And if I grep against it, I'm going to find it appear a whole bunch of times. Now we're going to use the stream editor on it. First, pardon me, we're just going to use sed. So sed's a little bit different, and many utilities are, but basically we're going to use the stream editor. We're going to seek the pattern APLE, and P means print it when you find it. So let's try it out and see what happens. Okay, so it seems to be printing, I don't know if you can see that very well, but it's actually printing every line of the file, and then it's reprinting where the target pattern has been matched. So it prints the misspelled apple pie, And then the reason it prints it again is because sed has found that pattern and is applying its print command to it. So if we change that command and add the -n option, what will happen is sed will no longer just print everything. It will only print when it's doing work. So that's what the -n does, is tells sed, I don't want to see everything come back out, I just want to see when you're doing work. So now we're only seeing the lines come out that have APLE in them. Now that's a hard way of grep APLE shopping, right? So that's not super useful yet. But you can use sed to also filter out targeted lines with targeted patterns. All right, so now let's do something slightly more interesting with it, which you'll see sort of down here. So it's something slightly more interesting. We're just going to keep using -n, so we only see, well, we'll try it with and without and see what happens. So another thing you can do with sed is do a substitution. So the S is a substitution. It's followed by a slash, followed by, this is like a find and replace basically. So what am I looking for? APLE, followed by a slash, followed by, if you find it, what do you want to replace it with? Followed by a slash. So what I'm telling sed to do is look for substitute for APLE with APPLE. And then I'll tell it the file to do that in. So notice, by the way, I took the, I tried it with -n and got nothing, so then I tried it without -n, and I have to look, but I'm seeing where it fixed apple pie. I don't remember what the other lines were. I think it was this one, apple a day. Anyway, I don't see the misspelled apple anywhere anymore. So in the case of a substitution, it seems like it's better to not use the -n. Just sort of pointed that out and found it out by experimentation. Okay, let's do something else. I forget what I asked about, but let's find something else that might be interesting to play with. Apple barrel. I'm looking for a line that has the same word on it more than once, if I can find that. Which I can't. Okay, but let's just try a couple of other substitutions. So we'll replace, just going to pick one. Let's see, how many juices do I have? I have apple juice, orange Julius. I'm just trying to pick something that might be interesting to replace. Away. We'll just say, I'll change the away on here to happy. So I want to substitute for everywhere I find away with happy. I'm going to do it in all caps so it's easy to see in shopping list. And then you'll notice happy coming up. I wish I had a global one. I might have to do an edit so that we can try this other thing. So let's do an edit in here. I'm just going to add a line at the bottom. Because I want to show you one other thing that you can do with sed, of the basic sed. So note again that the idea here is sed allows you to filter and edit text on the fly, stream editor, and it uses regular expressions, which is why it comes up today. So we have it in the mix so that we can practice our basic regular expressions. So I want to show you 1 and 1 is 2. So I added that line at the bottom. So if I do a substitute 1, I'll literally just put the digit 1 in instead. So I want you to notice on the last line, it only replaced the first occurrence of 1. So by default, the substitute command will only, oh look, it picked up another 1 there, but it will only apply to the first occurrence. So if you want it to apply to all occurrences, you put a G at the end, and that means global. So the G globalizes the substitution, which means that every occurrence on every line is substituted for. So now that last line, both occurrences, because I used the global option, was said. Okay, still doing okay on time. So that's said. And again, for the most part, when you're doing the homework, try all the different command options that I've given you just to see what they do, but in trying them, you should be able to identify the one that is the correct answer, but some of the options that are the wrong answer still do something, perhaps, and you can sort of observe as an experiment what they do. Okay, so that's what these notes are about, though. Let's put that print one with the dash n, because that was where that was most useful. And then we did a substitute for the old with the new, find and replace first occurrence only, or global occurrence, which means every occurrence on every line where it's found. Okay, so that's the basics of SED. It can do a lot more than that, but that's a good first look at it. Now the last one of the day, which is awk, which is also a place where we can use regular expressions. But we'll start with the basics of awk. If you look at awk, it's probably seems a little bit scarier, and it doesn't immediately offer options. So pattern scanning and processing language. So grep is literally just, can I find the pattern in a file? Which you could use for things like, I want to see if this hacker user appears in this log file. I can grep for their username in my log file. The stream editor, SED, is good for interactive processing and editing. So, I had my old version of the shopping list where I misspelled apple everywhere. I can stream edit it and replace all the misspellings of apple with a new spelling of apple. Oh, and I didn't close the loop on that, but probably global. So if you want to keep your work, you would redirect it rather, to a new file. So anyway, I'm not going to run that command. I can run it, doesn't really matter. So if you want to keep your stream edits, you can redirect the output. And this can be a lot faster than opening up VI and doing an edit if you kind of know that you have the same thing that you're replacing over and over and over again. Then SED might be a faster option. Okay. Now to awk. So awk uses regular expressions, but before we do that, I'm going to use awk on my ratings file. So what awk is particularly good at, in my experience, in my usage of it, if you have a file that has a specific format in it, where every line, for example, is a category, and, pardon me, itch on my nose, a category and a product and a rating. If you have a file where every line follows a specified format, then awk is super smart at working with those files. It's particularly, well, let me just start with that. So you can, for example, so what awk is going to do, is it's going to scan your file and it's going to break it apart into its fields. So if every line has the same format, in this case 3 fields, then you can use awk to pluck off the fields. So field 1 is the first field on every line, which is all the categories. So you have to know going in with awk how many fields you have and what each field is. So I know, for example, and I can actually put a label in there if I want, I think, and label each field. So if I get the first field off every line of ratings, I get all the categories. If I get the second field off all the lines, then I'm getting the product. If I get the third field off the line, then I'm getting the rating. Now you have to know that your file follows a specific format on every line, and you have to know what that format is. So I had to know in advance that field 1 is a category, field 2 is a product, and field 3 is a rating to use awk. So that's fairly important about awk. You have to know how the file is formatted. Now you don't have to just pick off one field at a time. You can pick off, for example, just the this would be the product and the rating. I didn't put a space in there, so no space appears. In fact, I'm going to put a comma. So, but I knew because field 2 was going to be a product, field 3 was going to be a rating. You can put them in backwards orders. So I can, for example, say print the product. For some reason I'm having trouble. Followed by, I'll put an arrow this time just for fun, followed by the category instead. So you can actually use awk to change the ordering of things in the output. So I've used the product, and then I put a little arrow in there, and then followed by the category. That's kind of a cool thing. And you can also do things, so that's basic awk. If you have a file that has a specific format in it, then you can use awk to pick off the pieces. Pardon me. Okay, so now let's add regular expressions into the mix. So now what we're going to do is we're going to pick off all of the lines that are snack foods. So I'm going to use regular expressions to do this. This is going to look a little bit like said. So I'm going to pick off all the lines that start with snack. This is how you do it in awk. And then what do I want to do with those lines? I want to print just the food. So in this case, I'm combining a regular expression that targets specific lines with an operation to print out the product name for those lines. So those should be all the snacks. Fritos, pretzels, gummy bears, and apple chips. So I printed the snacks. I used a regular expression to target which lines, the lines that start with the word snack in them. I could also print, let's just say the product name for every line that has apple anywhere on it. So apple juice and apple chips. It turns out in that case that was the product names in both. I could have also put the rating in if I wanted. I'm going to do it kind of fancy this time. So I'm going to put the rating inside of parentheses, and I left an extra space, so it'll have the rating is field 3. The rating with parentheses around it, and then a space, and then the product name for every line that has the word apple on it. So apple juice I find meh, apple chips I find yummy. I could look for all of the meh lines. In that case, maybe instead of the rating, which I already know, I'm going to get all of the, probably I should have anchored the meh. So now I'm starting to go a little bit probably too fast. But the difference between meh and meh with the $ is that that's meh if it appears anywhere in the line. In this case, meh if it appears specifically at the end of the line, the anchor. Print the first field and the second field. And then you can use the little extra formatting if you want to. So awk is really, really cool. You can use regular expressions to pick off specific lines that you're interested in, and then you can use awk's ability to break apart things to just pluck off the specific fields that you want. Hopefully that makes some kind of sense. Let me see how much time I have. I'm starting to run out of time. Okay, I think that's most of what you need. Hopefully that's most of what you need. So we looked at the most basic components of regular expressions. That a regular expression starts with the string that you want to match, and then you can modify it. So you can modify it with character classes, you can modify it with anchors, and then you use the best utilities to explore regular expressions on Linux are grep, which is just seeking matches in files, sed, which actually uses the matches to perform edits, and then awk, which can use the matches to actually, in the way we're using it anyway, to filter specific fields out of a sort of a text database file. So I think those are all, they're a lot of fun, and they're more fun if you have a file with stuff that you're familiar with to work with. So I've given you the shopping list file as an idea, but put things in there, make some misspellings, and then use grep, sed, and awk to seek out and do corrections. And then I've also did this ratings file, which is the fixed format file, which is fun to use awk with. And sorry, my voice is starting to be a wreck. Let me see if there's anything else I want to say about awk before we leave. Yeah, so I'm going to go ahead and go for it real quick. I don't think you need this, but I'm actually going to use my abilities here. So what I'm going to do, I'm going to use the stream editor on this file to replace all the spaces with colons. So I'm going to replace, so substitute for, I think, well, let's use a print first just to see. So can I just print? No, that's not going to work. Let's just try it, see what happens. Substitute for spaces, colons instead, all of them on every line in the ratings file. Okay, so that is what I wanted. And now that I know it works, I can redirect it to a new ratings file. So that now I have a flat file database, but notice that the fields are now separated by colons instead of spaces, so it's snack colon or category colon product colon rating. So by default, awk wants spaces in there. But you don't always have spaces to work with. So how do I get awk to work? So how do I get awk to work if it can't find that there's 3 fields anymore because there's no spaces? The way you do that is you pass awk the field separator option, and I think you probably have to put quotes around it. So what I'm telling awk here is you're going to find that the fields are separated by colons this time. So assume that colons are separating the fields, and then give me the 3rd field on every line of new ratings. That was not an interesting field to search for. And let me give you a real example of that. So if we look at the password file, which is etc. password, so every line is a username separated by a colon from a hashed or encrypted password marker, separated by a colon from their user ID, colon, group ID, colon, real name, I think, colon, home directory, colon, shell. So in the password file, there are 1, 2, 3, 4, 5, 6, 7 fields separated by colons, not spaces. So what if I wanted to use awk to get the home directories of all the users on the system? Or let's in fact say the user and their home directory. Well, that's field 1 and then field 2, 3, 4, 5, 6. So I need field 1 and field 6 from this file. So I'll use awk. I need to specify that these fields are separated by colons. And then the operation I want is field 1, the username. I will put an arrow in there because I think that looks pretty, followed by field 6, which is their home directory in that file, etc. password, which gives me every user in the system, followed by an arrow, followed by whatever their home directory is supposed to be. I will confirm that with my own self, who am called user. Here I am. And there is my home directory, home user. So anyway, that's kind of a real example where I have a file where I have 7 fields. I want 2 specific of them, but awk by default wants spaces. So if it's not spaces, you can say actually the fields are separated by something different. In this case, a colon. awk is super awesome. If you're into such things, awk is actually a programming language. So you'll find extensive examples out there in the world where people have used the full programming features of awk. For me personally, I almost always use it just to pluck fields from plain text database files. But it can do a lot more than that. Okay, so now we're into bonus material. So how to say this? I'm going to change my display so that people watching the video later will see this. Make it really, really big. Okay, so what's coming is bonus or optional. It's just going to be a couple minutes. It assumes this material assumes that you've installed at least Xface, if not the others. So what I'm doing is just sort of adding one other thing on top of what we did last week. So if you don't have the window manager stuff, this bonus material won't apply. But if you do, then let's add a web browser. All we're going to do is install a web browser and then take advantage of the fact that now we have graphics, we can use a web browser. So that's what we're doing here. Okay, so you can actually do this. I'm going to do it from here, and then I'll start open box probably, because that's the simpler one, just to make sure that it works. So we're about to install software, and typically before I install software, I do a sudo yum update. I want to make sure that my current software is up to date, and I also want to make sure that my database of available software is up to date. So before I install something new, I usually go through this update procedure. No, I'm okay. I know my voice is just shot. Okay, so hopefully you're not having to wait on updates. If you are, you can let me know in chat. But probably if you've done the window manager stuff recently, then you're in the same state as I am, and you don't have any updates to do. So we're going to add. You have two choices here. Firefox would be the most common one. So you can install Firefox, which is, I guess, what I'm going to do. It's probably big. So we'll have the Firefox web browser. Yeah, not small. Okay, so if you're still with me, hopefully that process is going okay for you. That's all I'm going to install is Firefox. I'm going to check my exinit.rc to see. I need to be in the home directory. Make sure you're in home. I guess I could have just made sure of that. Okay, so I'm using i3, so that's fine. Let's see how it works in i3. Although you're going to need my notes here, so let me restore these. Make this not super crazy gigantic anymore. Let me get my notes back. Where'd you go? Okay, so I have my notes down here. I did a sudo yum update. I did a sudo yum install Firefox. If you want to double check your exinit.rc, which we should say, make sure that's the one in your home directory, that it's going to launch your desired window manager. I'm going to do i3 because that's actually the harder one, so I might as well show you that. We're going to start X, and then so I'm going to do Alt-D, and that's going to bring up a little menu, and then start typing Firefox. So my exinit.rc is currently set to start i3 when I do start X, so that's what I want. Okay, so remember I3 is like the most intimidating one. I can get a terminal up by doing Alt-Enter. And I can quit the terminal by doing Alt-Shift-Q for quit. Now, if I want to run Firefox, which I now installed, I'm going to type Alt-D. And you can see at the top there's a little menu thingy. So if you start typing what you're looking for, like Firefox, it will come up, and I'm going to hit enter, and hopefully it just launches it. Firefox is a memory hog, so it could take a second to open up. And we're here. We have Firefox with just awful. My mouse is just dying. Poor mouse. Notice, by the way, I don't think that there's any window controls on here. You do have the file menu, except for you don't have the file menu. Look, I can't get to it. Can I get to it? Yeah. Oh, that's very strange. Oh, no, that's not. I don't have a menu. That's my VM. So there's no menu, but you do have... Oh, I was already there. Anyway, now we have graphics. Let's see if I can... Yeah, so I can hold the control key down and use the mouse, middle mouse button to zoom it. So that's nice. Should be able to follow a link. So that all works. To get out of here, since we don't have any Windows control on i3, I can do Alt-Shift-Q to quit whatever program you're running presently. And then I quit. Alt-Shift-E to exit out of i3. So anyway, that's just a tiny bit of bonus content. You might switch around between your different window managers just to see what it looks and feels like in the different window managers. So let's see if it shows up under Applications in OpenBox. Internet. Hey, it does. So OpenBox automatically found it. And in OpenBox, notice it's a little bit, has more sort of user-friendly features, so it's got the Windows controls on it. If I minimize it, where does it go? I don't know where it went. I have no idea where it is. In OpenBox, if you middle mouse click, you get to your, you have different workspaces, but it'll also get you the list of windows that brought it back. Middle mouse click to get it back in OpenBox. But you know how to do those experiments. Just start clicking stuff and see what happens. So there you go. Let's see if it will go to real CentOS. It will. And then I can exit it here. Can log off of OpenBox. Okay, that's everything I got. So we start doing shell scripting next week. We're just going to do the most basics again. But starting next week, pretty much the rest of the semester is the basics of shell scripting using the Born Again or the Bash shell. So thanks for tolerating my voice is just shot already for the week. Sorry about that. I hope you all have a great week. Let me know on Piazza if you have questions, or by Canvas inbox if I can be of any assistance. Otherwise, I'll see you next Tuesday. I hope you have a good day. I hope you have a good week. And I will see you again at 11 on Tuesday next week. So take care.